Hello. Good evening, guys. I hope everybody is there. Oh, yeah, everybody is there. Okay. Right. So today, the second time, right? So we will be looking at the second chapter. Last class we saw chemical reactions and equations, right? So today we'll be saying acid, bases, and salts. I think you would have gotten the assignments, right? Okay. Just give me a moment, guys. Just give me a moment. Right. So, as the name tells you, right? So we will be studying about acids, bases, and salts. Okay. Right. Fine. First, we'll look into what exactly acids are, what bases are, and what salts are. You already know it, right? Fine. So when I talk about acids, people, right? When I talk about acids, right? So tell me, like rather than me teaching, we will have a sort of discussion, right? Okay, tell me, what exactly are acids? How do you define acids?
Anything which provides H plus ions in the presence of water is termed as acid.
Correct. So I have a species, I have a chemical species, right? So that chemical species will have to be dissolved in water, right? That chemical species has to be dissolved in water. And if it gets dissolved and if it gives me H plus ions, right? So those are what are called as acids. Okay, pretty cool, right? So a little more extra information if I have to give you, that particular thing which you're talking about, anything which gives me H plus when dissolved in water, that theory, that rule came from a scientist called as Arrhenius. Okay, so it was Arrhenius who gave that statement. Okay, it's called Arrhenius theory, right? So Arrhenius theory says that if you dissolve something in water and if it gives me H plus, right? So those are termed to be acids, right? So if I have HCl gas, right? So just because you have HCl, that doesn't mean that it is going to be an acid, right? So when I say HCl gas, it is not an acid, right? But same thing, if I tell you that it is HCl in aqueous solution, if I put AQ means what? It is dissolved in water, aqueous, right? That can be termed as an acid, okay? Because when it dissolves, it is going to give me H plus. Now, little more information to you, right? Now, Arrhenius theory doesn't work every time, right? What do you mean by it doesn't work? It doesn't work in the sense there are certain substances, right, which when dissolved in water does not give me H plus, right? But still they are regarded as acids. Okay, right? So like that means this is not the only theory. When you go to higher classes, you will see this is not the only definition, right? So you have, this is Arrhenius theory. You have something called as Lowry Bronsted theory, or you have another one called as Lewis theory. Okay, so these three are the predominant theories of acids and bases. Okay, now in your syllabus you have only these two, but these are not that difficult. It is very easy, right? Say for example, if I talk in terms of Lewis theory, right? So whichever is able to accept electrons are what are called as acids, right? And whichever is able to donate electrons are what are called as bases. Okay, right? Accepting electrons are what are called as acids, and whichever is able to donate electrons are what are called as bases. For example, do you know ammonia is a base? Yes or no?
Yes, sir.
Right. Okay. Tell me, how will you prove that ammonia is a base?
Sir, when ammonia is dissolved in water, it provides OH minus ions, sir.
Correct. Right. So when I have NH3, when I dissolve NH3 in H2O, you will basically get NH4 plus, or basically you are going to get NH4OH, which will dissociate to form NH4 plus and OH minus. Isn't it? Right. So this is how we prove it. Right. When I dissolve ammonia in water, and basically ReNH3, the basis definition, whenever dissolved in water, it gives me OH minus. That is what is called as a base. Okay, right. Right. So you see that it is going to give me OH minus, but okay, this is one of the way. Right. Now there is another way of speaking about it. Now you see, hope you know electron dot structures. Do you know electron dot structures? Lewis dot structures?
Yes, sir.
Right. So if you draw that for NH3, what you will find is, right, this ammonia has, then on nitrogen, you have 2 electrons which are not involving in bonding at all. Basically, nitrogen has 5 electrons in the valence shell, right? 3 of them are involving in bonding, covalent bonding with hydrogen. One electron is going to come from hydrogen. So 3 electrons are gone. 2 more electrons are left out in nitrogen, right? Now, these 2 electrons can be donated to some other species, right? And that is why we say that it is a Lewis base. What do you mean by Lewis base? Whichever is able to donate an electron is what is called as a Lewis base. This electron which is there, which is not involved in bonding, right, can be donated to some other species, giving it as a Lewis base. Okay, fine. So these are not extra information. All you have to know is about H plus and OH minus. It's just extra information to you, right? Maybe when you come to 11th class, there is a chapter called as equilibrium, right? So at those things, you will be studying in depth about all these concepts. Just giving you a hint, right? Okay, fine. So now we know what exactly are acids and bases, right? Now what you have to understand is how can acids be classified? Okay. Now you tell me, what are the ways in which acids can be classified?
Depending upon.
Sorry, one by one. Yeah.
Sir, depending upon the concentration of H plus ions, it provides in the presence of water.
Okay. So what is the name of the classifications?
Strong acids, weak acids.
Okay. Now this is a constant confusion, right? Right. See, I have, oh God, all markers are bad. Okay. Concentrated, diluted, and I have strong acids and weak acids. Okay, one second. Right. Okay. So now these two are entirely different. Concentrated and weak acids come under one classification. Strong and weak acids come under some other classification. Okay. Do you want to comment on this? How these two are different? Concentrated acid means it is not a strong acid. Please don't think like that. I think there was a question in your assignment also, isn't it? There was a question, right, regarding this concentrated acids versus strong acids. I think they asked you to differentiate between what is a concentrated and a strong acid. How do you differentiate? Tell me.
Concentrated acid is the acid when dissolved in water gives out more H plus ions, whereas a strong acid in acid itself, for example HCl, it's a strong acid, whereas an acetic acid, it's a weak acid.
Okay, fine. See, proper way of telling it is very, very simple, right? See, when I'm going to make an acid or base solution, this goes along with your bases also. Okay, concentrated bases, dilute bases, strong bases, weak bases. Okay, the same thing goes along with bases also. Okay, so what you have to understand is, people, right? You're going to make a solution, isn't it? You are going to make an acid solution or you are going to make a basic solution. What you're going to do, if you want to make a solution, you are going to add something called a solute. You are going to add something called a solvent, right? So this, for example, if it's an acid solution, right? If it's an acid solution, the solute you will use is what is your acid, and the solvent you use is what is my water. Is it not? Right? The solute used is acid or base, depending on what solution it is. And the solvent is obviously going to be water, right? Now, when I'm going for concentrated or when I say diluted, it is all about which is higher, right? Whether the solute is higher or whether the solvent is higher, right? Not exactly higher, right? For example, right, I have very little amount of water and a very large amount of acid in the solution. That means large amount of solute and very small amount of solvent, right? Now that is what is called as a concentrated solution. When I say concentrated, that means there is higher amount of solute present. That is what you have to understand. It has nothing to do with the amount of H plus it is going to give. No, it is just that I have very large amount of acid, very little amount of water, or large amount of base and little amount of water. That is what you need to understand by a concentrated acid or concentrated basic solution. Please remember this. It has nothing to do with the number of H plus or the amount of H plus it is going to give. Relatively, comparing the amount of solute and solvent, if I have higher amount of solute, concentrated solution. If I have higher amount of solvent, then comes your diluted solution. How do you dilute a solution? Basically, you add more and more amount of water, isn't it? Right? So a diluted solution will generally have large amount of water. A concentrated solution will have large amount of solute. That is your acid or base. That is how you need to define it. Okay, it has nothing, literally nothing to do with the amount of H plus. Please understand. In fact, if you have a concentrated solution, the amount of H plus coming would be little less. Please understand that. Okay, if you have a highly concentrated solution, right, you like the amount of H plus coming would be pretty less compared to a dilute solution. And dilute solution, the concentration of H plus, or say in dilute solution, the amount of H plus is little higher when compared to concentrated solutions. The amount of acid may be more. Please understand. In a concentrated solution, the amount of acid may be more, but when it has to dissociate, isn't it? The acid has to dissociate to give me H plus. That does not happen. That does not happen means it is going to happen in a very less amount. But in diluted solution, even though I have lesser amount of acid, almost all the acid molecules will give me H plus. Right? Now, how you will understand this is, people, please understand this. When I have generally I have an acid HA. Okay. Now, when I'm going to dissolve it in water, then only you will form this H3O plus ion and the A minus, whatever the anion you're going to form. H3O plus or H plus. H3O plus is what is called as your hydronium ion. We all know this, right? H3O plus is hydronium. Do you all know?
Yes.
Right? H3O plus is hydronium ion. Okay. So what you're understanding here? If you have very less amount of water, this dissociation will not happen smoothly. But if you have large amount of water, obviously more and more dissociation will happen. So concentrated acids are not strong acids. Please remember that. Concentrated acids are going to have more amount of acid solution, less amount of water. Dilute solution opposite. Less amount of acid, more amount of water. Did you understand, people? What is the difference between, basically what you have to understand is concentrated acids are not strong acids. Did you understand that point? Yes? No?
Yes, sir.
Right?
Yes.
Understood.
Okay, cool. Now coming back to this, what do you mean by strong acid? Okay, if concentrated acids are not strong acids, what do you mean by a strong acid? Let me take an example. Right. So example, I don't know the name. The girl said, hey, HCl is a strong acid, acetic acid is a weak acid. We'll see how. Okay. Right. Say I have HCl 10 ml. Okay. And CH3COOH, that is your acetic acid, also to be 10 ml. Okay. I have two test tubes. Okay. 10 ml of acetic acid, 10 ml of HCl solution. Sorry. Right. HCl. Right. Okay. To this, I add, say, 100 ml. I had water to this. Okay. Let me take another marker. Please give me a minute. right? Okay, so we took 10 ml of HCl, 10 ml of CH3COOH, right? Now I say with this HCl, I add 100 ml of water. To this also, I add 100 ml of water. Okay, right? Fine. Now, what you understand is both these solutions is concentration. Okay, first thing, before we see this, tell me what is concentration of a solution? How do you define it? I'm not asking you concentrated solution. No, I'm asking you, what do you mean by concentration of a solution? Means what?
What is present in the solution?
Something present.
Sorry, one answer I heard. Next answer I didn't hear. What is it?
Amount of something present.
Correct. That's the correct answer, right? So basically, when I say concentration of a solution, basically I'm talking about amount of solute present. That's it. As simple as that. How much amount of solute is there for a given amount of solvent? Okay, for a given amount of solvent, how much amount or what mass? It can be terms of mass. You might have studied number of moles, right? I don't know whether you studied mass percentages. In 9th class, I think you would have studied, right? Mass percentage. Did you study mass percentages? I don't remember. Okay, fine, no issues. We are not going to talk about all those. So when I say concentration, concentration means amount of solute. Okay, now do you see this? For these two solutions are having 10 ml of this, 10 ml of this, 100 ml of this, 100 ml of this. Can I say they have equal concentration because they have equal amount of solute, that is HCl and CH3COOH, both to be 10 ml in 100 ml water. Okay, both these solutions are having equal concentration, or I can say they are equally concentrated solutions. Are you understanding my points? There are two ways of stating this. One is they are having equal concentration, or if I talk about this, they are equally concentrated or they are equally diluted solutions, however you want to call it. Okay, fine. Now I know this is going to give me H plus or say H3O plus Cl minus, and I know this is going to give me H plus or H3O plus CH3COO minus. Okay, but this dissociation reaction is going to happen. Right. Now, we are talking about strong and weak acids, correct? Right. If you see out of this 10 ml, right, after the reaction has gotten over, maybe, I'm just giving you a rough estimate, maybe almost 9.9 grams, or say remaining is only 0.1 gram. After the reaction is completed, right, I check what is the amount of HCl present in the solution. Okay, and what I found out was 0.1 gram of HCl is only remaining. Right? Obviously, all the what is the HCl? So basically, 9.9 grams of HCl has gotten into the solution, has gotten in the solution as H3O plus and Cl minus ion. So basically, 9.9 grams of HCl has dissociated. Okay, fine. Now, if I take CH3COOH, right, and I see after the reaction is completed how much amount of acetic acid is present, I find that almost 5 ml of CH3COOH is present. What do you mean by this? Out of the 10 ml, only 5 ml has gone to dissociate. Rest 5 ml stays as this only. Right? So now I think I'm getting to the point. When I say strong or weak acids, the only criteria is extent of dissociation. Right? How much dissociation is happening? If I have same concentration, see, these are same concentration, I'm not changing anything. But what you see in HCl is almost all the HCl went to give me H plus and Cl minus, but only 50% of CH3COOH gave me H3O plus and CH3COO minus. Okay, so please understand strength of the acid. When I say strength of an acid is directly proportional to the extent of dissociation. How much? If I from some amount of acid, if all of them gives me H plus and now whatever the anion, those are termed as strong acids. and if very little amount of that particular acid gives me H plus and whatever the anion, those are going to be called as weak acids. Okay, so hope you understand the difference. Concentrated dilute solution is going to depend on the amount of acid or base present, right? Now, when I say strong or weak acids, it is based on strength, and this strength is going to depend on how much dissociation is happening. Okay, hope you understood the case here, right? Now, everybody understood what is the difference between concentrated and diluted and strong and weak. Everybody is okay?
Yes, sir.
Yes, sir.
Good, right? Fine. So this confusion I think students will have. Concentrated solutions are not strong acids. Please understand that. Okay, right, cool, fine. So that is 2 of the classification. What are other classifications we can have for acids or bases?
Sir, mineral acids, organic acids.
Good, right? So when I say, or I would say organic acids and inorganic, or organic acids and mineral acids, whatever it is, right? So from the name itself, you can tell organic acids are going to be derived from nature, right? Mineral acids are generally from minerals, or we chemically synthesize them in laboratory. Okay, so like there are so many organic acids, isn't it? Say for example, okay, we'll list it out. Tell me what are all the organic acids you know, and what are all the sources? Come on, one person, one thing.
Citric acid from lemon and orange.
Okay, citric acid from lemon and orange. Okay, then.
Sir, tartaric acid from tamarind.
Okay, tartaric acid from tamarind. Okay. Come on, everybody participate. You obviously know, right? At least one thing you will know. Come on, bring it on.
Sir, lactic acid from tomato.
Oxalic acid from tomato. Okay, one more thing someone said.
The lactic acid from curd.
Lactic acid from milk or curd. Okay, good. Then
So acetic acid from vinegar.
acetic acid from
Vinegar.
vinegar. Good. Okay. What does an ant bite?
Formic acid.
Ethanoic acid.
Formic acid. Right. Okay, so these are all the different types of organic acids. And when you go to maybe higher classes, you will even study what is the structure of other. For example, oxalic acid, if you take, right, the structure would be like this: COOH, COOH. Right, that's the formula for oxalic acid. Citric acid, everything will have a formula. When you go to 11th or 12th class, maybe some of them, not all of them, but little of them, you will be studying. Okay, so that is about other classification. Okay, what is the next classification?
Sir, in bases, normal bases and alkalis.
Okay, makes sense, right? So basically, again, okay, that is one way of looking at it. The same classification can be put in other words. How can I put it?
Diluted and concentrated.
The opposite, strong and weak acids, right? So sorry, not acids, bases, right? So we know, right? Okay, when talk about bases, right? Now, please understand, people, strong bases are only 3. There are only 3 strong bases. Rest all are weak. Okay. So can you tell me what are all the 3 strong bases?
Sodium hydroxide,
potassium
Okay.
hydroxide.
potassium
Okay.
hydroxide, calcium hydroxide.
That's it. Right. Now, these 3 are only the strong bases. Among this, obviously, these are what are called as alkali bases. Or generally, I can say actually all of them are alkali bases. Okay. Normal bases are going to be weak. MgOH twice, LiOH, aluminium hydroxide. All these things are going to be weak bases. Okay, fine. Anyways, that is good one. Okay, next. What is the next classification?
Based on the oxides.
Based on the
oxides they give out. Acids give out non-metallic oxide.
Okay, good. You should say the other way, right? Basically, what do you have to say?
Acids give non-metallic oxides and bases give metallic oxides.
No, not that, not that way. So what I'm telling is, when I have a non-metallic oxide, and when I add water to it, I am going to get a base. This is how you must tell, not the opposite way. Okay. Now, when I have a metallic oxide, oh, sorry, this is going to give me an acid. I'm sorry. right? I'll give you an example, don't worry, right? So when I have a metallic oxide and when I add acid to it, when I add water to it, I am going to get a base. Very simple. For example, right? So if you have a non-metallic oxide, say for example, you have SO3, sulfur trioxide, right? Now sulfur trioxide, when you add water, you are going to form H2SO4. See, this is a non-metallic oxide reacting with water to form H2SO4, right? Same way, say if I have a metallic oxide, like say calcium oxide reacting with water, and this is your famous reaction, isn't it? This is what is called as Laker lime. This is what is called as quicklime, right? So again, you see there's a metallic oxide reacting with water to form calcium hydroxide. So base, non-metallic oxide acids, metallic oxides bases. Okay, anyways, a good point, very good point. Okay, next, what are the classifications? See, what are other types of classification?
There are reactions with metals.
Yeah, chemical reactivity definitely will be different. Other than that, without going to chemical reactivities, other than that, okay, maybe I'll give you a term. I have something called as acidity, basicity. What are these? Acidity and basicity. Okay, right. So please understand, acidity and basicity are exactly opposite of what the name says. Acidity is basically number of H plus ions which can come from one molecule of a base. Now, sorry, number of OH minus. Sorry, number of OH minus ions coming from one molecule of a base. Right? For example, if I have NaOH, it can give me how many OH minus ions? One OH minus ion, right? But if I have, say, MgOH twice or CaOH twice, it is going to give me two OH minus ions, right? So NaOH is what is called as a monoacidic base because it is going to give me only one OH minus. Mono is one, right? Whereas calcium hydroxide is a diacidic base. Okay, so when I say acidity of a base means how many OH minus ions it can give. If it can give only one OH minus, monoacidic, if it gives me two OH minus, diacidic, if it gives me three, so like aluminium hydroxide, that is going to be triacidic base. Okay, so that is the same way it's going to be for basicity. Basicity is the number of H plus ions a particular acid can give from one molecule of the acid. For example, HCl is a monobasic acid, right? H2SO4 is a dibasic acid. H3PO4, phosphoric acid. What is the formula for phosphoric acid?
H3PO4.
Right. So H3PO4. So H3PO4 is a tribasic acid. Okay. So based on acidity and basicity, also you will be able to classify acids into monoacidic or diacidic or whatever it is, based on the number of H plus and number of OH minus ions the acid and base can be. Okay, fine. So these are all the different classifications I can have for acids and bases. Okay, and obviously chemical properties look different. You must know all the chemical properties, how acids react on metals, non-metal react on metals, right? So all these things, you know, all these things, we are not going to concentrate on that, right? So what we are going to concentrate is the next part of the chapter, that is your salts. Okay, what is the time? Okay, we have any doubts, people? Anything you want to ask me till now? Maybe it might be higher level than your book, than what you have studied. Whatever comes to your mind, you can ask. Is there anything you want to know? Okay.
So no, sir. No.
Cool. Right. Fine. So when I go to salts, right, we know how salts are produced. Neutralization, the famous reaction in your chapter. neutralization reaction. Oh, I forgot one important question. We'll come back to this, right? So when I go for concentrated and diluted solutions, right? So there's a famous question, right? How do you dilute an acid? There are two ways of doing it, isn't it?
Into the water with constant stirring.
Right. So that is a very famous question. Almost every year the question comes from the board exams, right? So what you have to do for dilution? You need to have the water, right? And to this you add drop of acid, and you have to constantly stir it. Okay. Why are we doing all this, Kana? Why are we not doing the
It's a highly exothermic reaction.
Absolutely.
And if we pour water to the acid, then it may cause it to burst.
Understood. Right. So yeah. So basically dilution is a highly exothermic process, right? And why we are doing like this is because water can act as a cooling agent. It can suppress the amount of heat produced, so that this is safer to do, right? But if you look at the other one, as you said, it might even end up in exploding or bursting. Okay, so this I wanted to tell you. Okay, good, fine. Right? Okay, so when I go to salts, right? So salts can be of 4 types: acidic, basic, neutral, and acidic, basic, neutral, and one more. What is that? Sorry, I didn't hear.
So I don't know. So.
Oh, you don't know. Okay, fine. Anybody else knows what is the 4th type of salt? Okay, so 4th one are what are called as amphoteric salts. Anybody has heard this amphoteric?
They react with both acids and bases.
Right. Exactly. So those are that type of salts. For example, you can have zinc oxide, aluminium oxide. All these comes under amphoteric salts or amphoteric oxide generally. Okay, no issues. Right. Okay. So these 3, that is acid, acidic, basic, and neutral, are coming from the combination of different acids and bases. This is amphoteric is by its own nature. It's not depending on how you produce it. Basically, all the salts are produced by reaction of acid and a base, isn't it? Right. But amphoteric is by its own nature, right? Say why someone is so good? Why someone is so good at studies and someone is not? It's because that is their own property, that is their own nature, isn't it? So just like that, amphoteric salts are by their own nature. It is not based on how you produce them, right? But these 3, right, are going to depend on what is the acid and what is the base you use for producing them. Okay, right. Now tell me, how do you form an acidic salt?
Sir, when there is a reaction between strong acid and weak base.
Right. So I have a strong acid and a weak base will give me an acidic salt. Any examples you want to give me, Kana? Or anybody can give me an example. Example for an acidic salt.
NaCl.
NaCl. Now NaCl comes from what acid and what base? You tell me.
So HCl and NaOH.
NaOH and HCl, right? Hydrochloric acid and NaOH, sodium hydroxide. Correct. Now don't you see what hydroxide? Sodium hydroxide. Yeah, correct. Right.
Sodium hydroxide.
Yeah, sodium hydroxide only. Right. So basically now what do you see? It is coming from NaOH and HCl. Now both these are strong, isn't it? Both these are strong, right? So this is not an acidic salt. This will basically be a neutral salt. When a strong acid and a strong base reacts, when they form a salt, they will always be a neutral salt, right? Okay, now tell me about this. How do you form an acidic salt? NaCl is not an acidic salt.
So magnesium chloride.
Magnesium chloride. Okay, makes sense, right? Okay, so magnesium chloride, how do you form it? Is by using MgOH twice plus HCl, right? So obviously HCl is a strong acid and MgOH is a weak base. Okay, makes sense. So example can be MgCl2. Any other example you can think of? Don't tell me chloride. Some other example can you give me?
Zinc sulfate.
Yes, zinc sulfate is okay, right? So zinc sulfate will come from H2SO4 plus zinc hydroxide. Zinc hydroxide is a weak base and H2SO4 is a strong acid, right? Okay, that also I'll take zinc sulfate, but zinc, fine, okay, we'll take it. And I can even have NH4Cl. Can you tell me what is the acid and the base here for NH4Cl?
Ammonium and chloride.
What is the acid? What is the base to produce this?
Chloride, HCl is the acid and ammonium is the base.
Ammonium is the base. Can you tell me
Ammonium
properly?
hydroxide.
Right. So either you should sell ammonia as the base or ammonium hydroxide as the base. Both of them are correct. Okay. So here I have HCl and NH3 or NH4OH. Anything is fine. Because we know how to produce NH4OH from NH3. You just dissolve ammonia in water, you are going to get NH4OH. So either you tell the base is ammonia or you tell the base is ammonium hydroxide. Both are fine for me. Okay, cool. So now we understood how do you identify. They'll give you a salt and ask you to identify whether it's an acidic salt or a basic salt or neutral salt or amphoteric salt. You need to understand how you're going to do it. It is all going to depend on what base and what acid it is going to come from, except for amphoteric oxides. Okay, fine. Basic. So now in this case, I have to add a weak acid and a strong base. Examples.
Sodium carbonate.
Sodium carbonate makes sense, right? So sodium carbonate, how do you form? Right, sodium carbonate, you are going to have NaOH and H2CO3. What is H2CO3 called as?
Carbonic acid.
Right, good.
Carbonate.
Hydrogen carbonate is the salt name, but when you say acid, it is going to be carbonic acid. Okay. Okay, right. So now this is going to give me Na2CO3, right? So you see, this is a weak acid, this is a strong base. So definitely Na2CO3 can come here, even NaHCO3. Now why? Now in this case, you see both the H plus ions are lost, right? Both H2CO3 is there, both the H's are gone, right? But if at all you use only one, I can even form NaHCO3 plus H2 can come out. Okay. So there is sodium bicarbonate, that is sodium carbonate. Both are basic salts. Any other example?
Can calcium carbonate come under this?
Yes, calcium carbonate also comes under this, other than carbonates. Any other thing? Just mix, take a weak acid, take a strong base, any other weak acid you know, and mix it and tell me what you're going to get.
Potassium acetate.
Good, right? So when I have say NaOH plus CH3COOH, I know this is a weak acid, a strong base. This is going to form, or NaOH or KOH, doesn't matter. Use of KOH, no issues, right? So you're going to form CH3CO minus and Na plus or K plus. It is potassium acetate or sodium acetate. This CH3CO minus ion is what is called as your acetate ion. If you want the name, sodium acetate is what is the name. So again, this also can come here. Okay, so these are all the different types of basic salt. Neutral salts, you know so much, right? You have NaOH plus HCl, NaOH plus H2SO4. Any strong acid and a strong base you take, right? All these comes under what is the neutral salts. That is very easy, right? So now looking at the salt, when I give you the salt, you must be able to understand what is the acid, what is the base, and depending on what is the acid and the base, you will be able to predict whether it's going to be a acidic salt or a basic salt or a neutral salt. Okay, and that you don't have to worry. Amphoteric are only two: zinc oxides and aluminium oxides. Okay, but what we'll try to do is we will do reactions of both of them, right? We'll prove that they are amphoteric in the sense that we have to prove that they can react with both acids and bases. Okay, we'll take some reactions for both of them, right? Okay. I hope there are no questions till now. Right. So we'll move on. Okay. Say for example, I have Z and O reacting with HCl. Okay. Tell me, what is the product you expect? Zinc oxide.
Zinc chloride and H2. Hydrogen.
Zinc chloride and
Hydrogen.
zinc chloride and water, not hydrogen. You see, if I write zinc chloride plus H2, where is this oxygen gone? Right? So basically, it is going to be H2O. So this is like an acid plus base reaction, is it not? See, this is a base and this is acting as an acid. What is happening? Salt plus water is getting formed. This is a neutralization reaction. Okay, we know metal oxides are generally basic in nature. So they can also act as a base. Okay, anyways. So you see zinc oxide is reacting with acid to form salt and water. So this means that it can act as a base or it can react with acid. Right? Now, when I have zinc oxide reacting with NaOH, do you know what is the product formed?
Sodium zincate.
Good. Can you tell me what is the formula for sodium zincate?
Na2ZnO2.
Good. Na2ZnO4 or O2?
O2, sir.
O2, right? So it is Na2ZnO2. This is called sodium zincate. Right? These kind of salts are what are called as what is they called as complex salts, right? But anyways, we'll not go into them, right? Okay. Same can go with aluminium oxide, right? Now same thing. If you do aluminium oxide reacting with HCl, you are going to form AlCl3 plus H2O, right? And here same aluminium oxide can react with NaOH and plus water, obviously. Here, right? NaOH is going to form, in this case, instead of sodium zincate, you're going to form sodium aluminate, right? So same formula, Na2AlO2. I think Na2AlO4, if I'm not right. Okay, so this is going to be sodium aluminate. Okay, right? Fine. So these are all the different types of salts. Now, what is more important is there are some special salts for us, isn't it? Washing soda, baking soda, washing powder, all the your plaster of Paris, gypsum salt, bleaching powder, right? So all these things you have to know how do you prepare them and what are their properties and what are they used for. Okay, so again, we'll just have a discussion again, right? So first we'll take bleaching powder. Fine. So okay, first tell me bleaching powder formula.
CaOCl2.
CaOCl twice. This is how you write. Is it not? Okay, Ca, it's calcium oxychloride. Please understand the name. Calcium oxychloride. So the twice is going to come for OCl together. Okay, oxychloride, OCl minus is the ion here. Again, we saw some of example, last class we saw examples for polyatomic anions or polyatomic cations. This is another example, oxygen and chlorine is there. Oxychloride ion. Okay, fine. How do you produce them? What is the chemical reaction?
Passing chlorine on dry slate lime.
Right. So you have Slakert lime formula. What is Slakert lime?
Calcium hydroxide. CaOH.
Right. Good.
CaOH.
Correct. So calcium hydroxide, when you pass Cl2, right, this should be dry. Right. Now you form CaOCl twice. Okay. So this is how you form the bleaching powder. Okay. Now tell me how bleaching powder. No, I know bleaching powder is it is helpful for cleaning, isn't it? It is going to act as a disinfectant, right? How? how bleaching powder, what do you mean by bleaching action of bleaching powder? What is the chemical reaction behind it?
Oxidation reaction.
Okay, fine, correct. Tell me the reaction. Right, so bleaching action. Remember, bleaching action is because of Cl minus ion coming out of calcium oxychloride. Please remember this. Okay, basically bleaching powder is going to, this Cl minus is going to oxidize the dirt or whatever the dirty particles. Okay, so if someone asks you which is responsible for the bleaching action of bleaching powder, your answer must be chloride ions. Okay, this chloride ions are the one which is going to oxidize the dirts. Okay, right? Very simple question, very simple answer. Okay, so this we know, right? So now we'll move on. Any other questions you have regarding bleaching powder?
No, sir.
Okay, cool. Right, so that's about bleaching powder. Right, so now next is about gypsum and your POP. POP?
Plaster of Paris.
Plaster of Paris.
Plaster of Paris.
Correct, plaster of Paris, right? Okay, so gypsum is basically anhydrous. Anhydrous, what? Oh, sorry, it's not anhydrous. I'm sorry. This is basically going to be hydrous. CaSO4 dot 2H2O is what is gypsum salt. Right? Okay. Now, when you heat it little, you are going to form calcium sulfate hemihydrate, half H2O is what is called as your plaster of Paris. Right? So calcium CaSO4.2H2O is what is my gypsum. When you heat it to some temperature, right, you are going to lose 1.5 water molecules, right, and you are going to form calcium sulfate hemihydrate, and that is what is your plaster of Paris, POP. Now there was a question, right, in your assignment. You obviously plaster of Paris is used for making different structures, different types of dolls or different types of statues, so many stuff, right? Now tell me whether that setting of POP, whether it is exothermic or endothermic.
Endothermic.
Okay, fine. See, what you have to understand is you have setting of cement. You know what happens in cement. Basically, you should have seen people building houses. Correct? Right? So they'll put the cement, and after some time, what happens is that is going to become stronger, but by water molecule getting evolved and all that. Right? Same goes with POP also. Now, please understand, this is both endo as well as exothermic process. Okay, setting of POP, right, is both an endothermic process as well as an exothermic process, but I don't think your book says this, right? So generally what they say is setting of POP is an exothermic process, but again, please check in your NCRT what is given to you, right? Technically speaking, it is both an endothermic as well as an exothermic process, right? Because some amount of heat has to come in so that all the water molecules will leave, right? And then obviously that is endothermic. Some amount of heat is absorbed and then the water molecules are leaving. And then you see it is also going to cool down, right? When you touch the wall after the cement, obviously you will feel that it is very cold. How? Basically some amount of heat would have been lost, right? So it is both endothermic as well as exothermic. But again, please check in your textbook what they have given, or please check in internet what they have given in Google, and accordingly you write in the exam. Okay, don't write both endo and exo. If they give both endo and exo, you give explanation. How is it happening? Okay, right? So that is about, and okay, what do you call CaSO4? No water molecule. What do you call that?
It's a calcium sulfate.
Okay, that is a chemical name. What is the common name?
Blue vitriol.
Blue vitriol is copper hydroxide. See, copper sulfate. Copper sulfate is that is what is blue in color. You must have seen blue color crystals of copper sulfate.
This is blue. Burnt slate.
Something like that, right? So, it's
Dead
called
plaster.
the dead burnt plaster. Okay, anhydrous CaSO4 is called dead burnt plaster. Okay, these are different names you have to know. So 1 mark question it will come. What is the common name of CaSO4? You must tell that it is going to be dead burnt plaster. Okay, right? So we saw about bleaching powder, we saw about gypsum, plaster of Paris, dead burnt plaster, the reactions involving them, right? So I think there is only a few things left. That is your washing powder and baking powder, right? I think we spoke about it in the last class itself. I think Na2CO3, NaHCO3, right? We saw that NaHCO3 can be used as an analgesic. What do you mean by analgesic? Analgesic? What do you mean by that? Anybody knows? So basically, analgesic are tablets which are used when you have digestion problems, when you have acidity, right? Your Digene, your tablet, right? All these comes under analgesics, right? When you have too much acid in your stomach, right? So at that time you go for these, right? So at that time you can either go for these tablets, and mostly these tablets will be made up of NaHCO3. NaHCO3 is a mild base, right? So that can go and it can neutralize the excess amount of acid present, right? Those kind of substances are what are called as analgesics, right? So NaHCO3 can be used there. Is any questions someone has? Okay, fine. And Na2CO3. Na2CO3 is washing soda or baking soda?
Washing soda.
Right. Na2CO3 is washing soda. Okay. But you should not say Na2CO3 alone. It should be Na2CO3.10H2O. This is what is washing powder. Okay, well, we should not say washing soda. This is washing powder or washing soda. Anything actually. They don't recognize. They don't differentiate much, right? So basically, when I say soda, it has lesser number of water molecules, and when I say powder, it is going to have more number of water molecules. That's what you need to understand. Okay, right? So that's about washing soda and baking soda, washing powder, baking powder. Very, very simple. Okay. So anything else is left, people, from the chapter? Obviously, one thing is left, and that is about your indicators, acid-base indicators, right? Okay. So we know what are indicators used for. Like I have an unknown substance, right? So I have an unknown substance, and I want to identify whether it's an acid or a base, right? So I go for these indicators, right? So I have different types of indicators. One is natural indicator. Natural indicator is what essence? Turmeric can be used. Okay, so turmeric can be a natural indicator. Right? I have one more, right? Natural, some essence, some
vanilla essence.
Vanilla essence is for olfactory indicators, isn't it? Olfactory indicators will be in terms of
Order.
No. Olfactory, when I say olfactory indicators, basically, generally indicators will give color change.
Oh, these are smell.
This is smell, isn't it? There'll be a smell change when it is going to be dissolved in acid or a base. Okay, anyways, right? So I have
under this too, right?
Sorry.
Onion peel or something.
Yes. Onion essence or onion peel also can come up. Yes, olfactory indicators, correct. Right? Okay. So I have lichens. This is what I was expecting. Right. So from this lichens, I remove an essence. So again, that from there only you produce litmus paper. Basically, from lichens only you produce your litmus papers. Okay, blue litmus paper, red litmus paper. Right. Blue litmus turns red in acid solution. Red litmus turns blue in basic solution. Right. All these things you already know. I'm just covering it up. Right. And one more thing is, these are all about qualitatively telling. Qualitatively means what? Instead of concentrating on how much is there, I'm concentrating on what is there, quality. Okay, so I can understand, okay, this is an acid, this is a base, okay, with the help of the indicators. But if I want to, okay, I understood that it is an acid. Okay, now I want to understand what is the strength of the acid. Now, when I go for quantitative aspects, quantitative means in terms of numbers, quantity. Okay, so when I go for quantitative aspects, right, that is where your pH comes into the picture. Okay, so we know, right, pH, but the pH is used for deciding the strength of the acid. pH scale will be from 0 to 14, right? So this side, if I go, basic strength increases, right? And this side, if I go, acidic strength increases, right? So for example, if I have an acid which is having a pH of 1 and pH of 2, obviously the acid which is having pH of 1 is a stronger acid than an acid which is having pH of 2. But if I have, say, bases, two things having 13 and 14 as a pH, right? The one which has 14 will be a stronger base than the one which is having pH of 13. So this and all we know, right? It will be from 0 to 14. This can be used as a universal indicator, right? Because for each and every, say, now you have 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever it is. For each of these, you can have some colors, isn't it? So accordingly, also I'll be able to tell. So this can use an indicator also, as well as it will be able to give me a quantitative number for the strength of the acid as well as the base. Okay, guys. Right. So I think I've covered everything. Is there anything I missed from your chapter? Okay, let me ask you a question then. Right. So I have 3 solutions with me, 3 test tubes with me. Okay, and one is an acid, another is a base, another is a salt. Okay, now say you have only red litmus with you. Only red litmus. Okay, this is A, this is B, this is C. Right, now tell me, with the help of red litmus only, tell me how will you identify which is acid, which is base, which is salt?
So
If
first,
it's
when we
base
put
red, then it is acid. If it changes to blue, then it is a base.
Okay.
And if
What about, how will you identify the salt? Salt
so it
also will
changes
not
to
give me.
purple color.
we should use the
No. Basically, what you're telling is correct. Red litmus will turn blue in basic solutions. It will not change color in acid solution. Okay. But what about salt? Salt also will not change color, isn't it? Then how do you identify which is salt, which is acid? Don't tell me how to go for pH. The only tool I have available is with this red litmus paper.
So
Yes?
first when we put the red litmus in basic solution means it turns into blue color, sir. And then
Okay.
using the same paper when we put in the checking in A and B means if A turns into red litmus means we can consider it as an acid, sir.
Good. That's the answer. I understood what you're telling. Very good. Very good. So what he's trying to say is assume that this is the basic solution. Okay. So when I put the red litmus here, now it will turn blue. Okay. So basically you try with all 3 of them, and in only one of them it turns blue. Okay. So now you try it out. That's it. Now you decide this is the base. Done. Okay. Now you have the blue litmus paper. Now how do you produce the blue litmus paper? The red litmus paper was turned blue by this basic solution. Isn't it? Right. So I take this blue litmus paper, I dip it here, wherever I see a color change. Obviously, acid solution will change blue litmus to red. So wherever it changes to red litmus again, that is the acid. And whichever doesn't give me any color change, that is my salt. Everybody understood what is happening here? Yes?
yes.
Yes.
Okay, with only one litmus paper, you first go put it in a basic solution, it turns blue. You put it in the acid solution, it turns red again. But same blue litmus, you put it in the salt, nothing will happen. So like this, with the help of only one indicator, we will be able to identify which is acid, which is base, and which is salt. Okay, so guys, did I miss anything in the chapter? You must have learned it. Did I miss anything? I didn't even go through the book. I just remember, okay, these are all the things should be there. Did I miss anything? Is it okay?
That's okay.
Okay, everything is covered. Okay, till then we'll wind up. If you have any questions, you can ask me. If you have any specific questions you saw in your exams and you didn't answer, you couldn't answer, anything like that you have? Or sir, I didn't understand this topic in this chapter, anything like that? Okay, I suppose everybody is doing well, right? So we'll meet again. So I think we have metals and non-metal chapter left. Okay, so that we'll see. That's a very small chapter. Okay, so that we will see. And then do you have periodic classification also?
Yes, sir.
Okay, so that chapter is taken out. Carbon compounds, is it taken out?
No, only homologous series is there.
Only
And like
homologous.
the,
No IUPAC naming?
what, sir?
IUPAC naming, the naming of compounds?
No. That's all deleted.
It's not there. Okay. Good.
Before saturated and unsaturated carbons, I mean, before that paragraph, everything is there.
Okay. Okay. Cool. Anyways, we'll see all that. Right. Okay. Fine, guys. It was wonderful having you. Thank you so much. We'll meet again some other day whenever they schedule it. Bye bye. Thank you.
Thank you, sir.
Thank you.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Thank
Thank
you.
you, sir.
You.